See, today's topic on spheres is orthogonal spheres. First I define what is the angle between the two spheres, then we define orthogonal spheres. Orthogonal spheres. See, the results in spheres are analogous to that of circles. You have studied orthogonal circles in two-dimensional geometry. That result is quite analogous, similar. But here only thing is we have three-dimensionalities, spheres. Now, angle between two spheres. First we define what is the angle between the two spheres. See, angle between the two spheres is defined as angle between the tangent planes at their point of contact or at the point of intersection. We consider one tangent plane here, one tangent plane, another tangent plane here, tangent plane. Angle between these tangent planes at the point of contact is at the point of intersection is called angle between the two spheres. Now, orthogonal spheres. See the definition. I think you followed what is the angle between the two spheres. It is the angle between the tangent planes at the point of intersection. Orthogonal spheres means if two spheres intersect or angle between the two spheres is 90 degree, two spheres are said to intersect orthogonally. Orthogonal means angle between the two spheres is 90 degree. How the angle between two spheres is defined? It is angle between the tangents at the point of intersection. Now, we know that suppose two spheres intersect orthogonally, then this is one point of intersection. These are the radii. These are the centers. I take A, B, P is one point of intersection. Suppose the two spheres intersect orthogonally at this point P. And you know that always radius is perpendicular to the tangent or tangent plane. Radius is perpendicular to the tangent plane. Therefore, AP, R1 is perpendicular to the tangent plane here. Tangent plane. And similarly, this radius R2 of the big sphere, that the second sphere, is also perpendicular to the tangent plane at this common point of intersection. Therefore, this is right angle. Now, hence, if two spheres intersect orthogonally, then what happens? The radii at the point of intersection are perpendicular. Important. When do you say that two spheres intersect orthogonally? Two spheres are said to intersect orthogonally if the angle between the tangents at their point of intersection is 90 degree. Since radius is perpendicular to the tangent plane, these two radii, if the two spheres intersect orthogonally, the radii at the point of intersection are right angle. Now, using this, we derive the condition for two spheres, standard spheres. So we take x square y square, 2u1x, v1y, w1z plus d1 is equal to 0, and x square y square z square, one more is there, z square plus 2u2x, v2y plus 2w2z, d2 is equal to 0 to intersect orthogonally. Now we derive analytical condition, because analytical geometry means we always study the geometry through algebra, using algebra. Analytically, first we derive one condition. What is the condition for two spheres to intersect orthogonally? How to derive that one? Using if two spheres intersect orthogonally at the point of contact or intersection, the radii of the two spheres are perpendicular. Now, the condition is 2u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus d2. This is the condition for two spheres to intersect orthogonally, and we derive this one. For that, suppose the two spheres intersect orthogonally, r1 r2 be the radii, p be the point of intersection, a and b are the centers. So APB is right angle. Therefore, AP square plus PB square is equal to AB square. Is equal to AB square. What is AP? Radius of first circle. Radius of first circle is U1 square, V1 square, W1 square minus D1 plus it's a square. What is PB? Radius of second circle. What is radius of second circle? What is the formula for radius? It is square root of u2 square, v2 square, w2 square minus d2, it's a square, is equal to ab square. What is ab? AB is distance between the centers. What is center of first circle? Minus u1 minus v1 minus w1. It is minus u2 minus v2 minus w2. Therefore, what is AB? It is equal to square root of minus u2 plus u1 minus u2 plus u1 whole square plus minus v2 plus v1 whole square minus w2 plus w1 whole square, because distance formula. What is the distance formula? x1 minus x2 whole square, y1 minus y2 whole square, w1 minus z1 minus z2 whole square under root. It's a square. It's a square. Now simplify this. What do you get? u1 square, v1 square, w1 square minus d1 plus u2 square, v2 square, w2 square minus d2 is square of this means u1 minus u2 whole square. u1 square, u2 square minus 2u1 u2, because this square root get cancels. Square root get cancels. Square is there. Square root get cancels. Plus v1 minus v2 whole square. v1 square plus v2 square minus 2v1 v2 plus w1 square, w2 square minus 2w1 w2. Now simplify this. Simplifying, we get u1 square, v1 square, w1 square, u1 square, v1 square, w1 square, u2 square, v2 square, w2 square get cancels. So we get minus d1 minus d2 is minus 2u1 u2 minus 2v1 v2 minus 2w1 w2, or all sign minus sign are there, multiplied by minus 1 both sides. We get, this is the condition. This is the condition for two spheres to intersect orthogonally. I think derivation was simple, but formula very important. You have to remember this as a formula. Condition for two spheres to intersect orthogonally. Just like you have remembered that center of this sphere, radius of this sphere, they are formula. Center of this sphere, radius of this sphere, etc. Now I take one problem on this. For 2 marks you may get some questions like this. I give later that type of example. Prove that following two spheres intersect orthogonally. Then you have to verify this condition. This condition. Then you have to verify this condition. u1, u2, v1, v2. You know how to write this u1, v1, w1, u2, v2, w2, and verify this condition. And also sometimes one variable will not be given here, one constant that will be given as k. You have to find out k so that two spheres intersect orthogonally. I consider that type of problem later. First problem is 5 marks problem here. Say on orthogonal involving these orthogonal circles. Problem 5 marks involving these formula. Take this problem. Find the equation of the sphere that passes through the circle x square plus y square plus z square minus 2x plus 3y minus 4z plus 6 is equal to 0. 3x minus 4y plus 5z minus 15 is equal to 0, and cuts the sphere x square plus y square plus z square plus 2x plus 4y minus 6z plus 11 is equal to 0 orthogonally. Understand problem? Find the equation of the sphere passing through this circle. As I already told, sphere and plane taken together represent a circle because their intersection is circle. And how to take equation of the sphere passing through the circle? Equation of this plus k times this equation. That represent a sphere passing through that circle. And to find out that k, it is given that resulting sphere should intersect this one orthogonally. Problem important. It is a 5 marks problem. I explain. Let the equation of the sphere is x square plus y square plus z square minus 2x plus 3y minus 4z plus 6 plus k times 3x minus 4y plus 5z minus 15 is equal to 0. Take this as 1. This as 1. Now given equation of the sphere as 2. This as 2. How to find out k? Now 1 and 2 are orthogonal. Using that you have to find out k and substitute here, you will get the required equation. 1 and 2 are orthogonal. What is the condition for orthogonality? 2u1 u2 plus 2v1 v2 plus 2w1 w2 plus or is equal to d1 plus d2. Now write here u1 v1 w1 u2 v2 w2 and substitute. You will get k. So the problem is simple. Equation of the sphere passing through the circle is equation of this plus k times second one is 0. Then to find out k, this is the required sphere which intersects given sphere orthogonally. Condition of orthogonality is this. Now we write down u1, v1, w1 so on. Now from comparing this with general equation, I take this as u1 is 1, u2 is 2, u1, v1 is 2, w1 is minus 3 and d1 is 11 because I compare this equation with x square y square z square 2u1x plus 2v1y plus 2w1z is equal to d1. Compare this equation. You will get u1 is, what is u1? u1 is 1, v1 is 2 because 2v1 it is, w1 is minus 3, d1 is 11. Now compare. Now I simplify further this equation. X square y square z square plus minus 2 plus 3k into x plus 3 minus 4k into y plus minus 4 plus 5k into z plus 6 minus 15k. Now compare this with this equation. v2y, w2z, d2 is equal to 0. So these two are the circle of spheres now. This is u2x, v2y, w2z. You have to compare with this with second equation, standard equation. So what do you get? U is, or I write here, 2u is minus 2 plus 3k, and 2v is 3 minus 4k, 2w is minus 4 plus 5k, d2 is 6 minus 15k. Correct? 6 minus 15k. Therefore, apply here. u2, v2, w2. Correct? w2. So 2u1 u2 is, it is 2u1 u2 is minus 2 plus 3k into 1 plus, I take 2v2 v1. 2v2 is 3 minus 4k into v1 is 2 plus 2w2. 2w2 is this, minus 4 plus 5k into w1 minus 3 is equal to d1 11 plus d1 plus d2 is 6 minus 15k. 6 minus 15k. See, this is also important. These small things, they are very important in while solving the problem. See, I have taken 2u2 u1 because I have written here 2u2. But while writing here, I have written only u1 v1 w1. u1 v1 w1. u1 is 1, u2 is that is v2 is v1 is 2 and w1 is minus 3. But while writing this equation, it involves k, so I have written 2u2 directly because we have 2u1 u2. I have taken 2u2 into u1, 2v2 into v1, 2w2 into w1 is equal to d1 plus d2. Now this gives value of k. Find out that k and substitute in 1, you will get the required equation. How to find here? Minus 2 plus 3, or I write one more step here, minus 2 plus 3k plus 6 minus 8k plus 12 minus 15k is equal to 17 minus 15k. 17 minus 15k. This cancels directly. Minus 8 plus 3k, say I write 5k, minus 8 minus 5k is equal to 18 minus 2, 16, 1, k is equal to minus 1 by 5. Am I correct? K is minus 1 by 5. Now substituting this in 1, required equation is, means equation of this sphere is x square y square z square plus x square y square z square minus 2x plus 3y. Refer that first equation. Minus 2x plus 3y minus 4z plus 6 minus 1 by 5 into 3x minus 5y, 3x minus 4y, 3x minus 4y plus 5z minus 15 is equal to 0. This is the equation. I think procedure all of you followed. What we did is, first we have written equation of this sphere passing through the circle, and we have taken that as 1. Since that sphere intersects the given sphere orthogonally, we have used condition of orthogonality. 2u1 u2, 2v1 v2, 2w1 w2 is d1 plus d2 to find out k, and we have obtained this as the equation: x square y square z square minus 10x minus 13x 15y plus 4y 19y minus 20 minus 25z 30 plus 15 plus 45 is 0. Am I correct? Minus 25z plus 19y plus 45 is 0. This is equation of the sphere. I think you all have followed where we have applied that condition of orthogonality. That was important. Next problem. Find the equation of the sphere that pass through. See, the problem is find the equation of the sphere that pass through 0, 3, 0, minus 2, minus 1, minus 4, all minus, and cuts orthogonally the two spheres x square plus y square plus z square plus x minus 3z minus 2 is equal to 0, and x square plus y square plus z square plus x plus 3y plus 4 is equal to 0 orthogonally. See the problem. Find the equation of the sphere passing through 2 points and cutting the 2 circles orthogonally. To find the equation of the circle, what you have to find out? 4 constants you have to find out. U, V, W, D. 4 constants. To find 4 constants, you require 4 linear equations in U, V, W, D. You have studied how to find equation of the sphere passing through 4 points. This is quite similar to that problem. Now, I explain required equation B. Equation B, x square plus y square plus z square, 2ux, 2vy, 2wz plus v is equal to 0. Take this as 1. Now by substituting these two, you get 2 equations because it passes through 0, 3, 0. Therefore, 0, 9, 0, 3, 0 plus 0 plus 6v plus 0 plus d is equal to 0. So we get 6v plus d plus 9 is equal to 0. Take this as 2. Then substitute minus 2, minus 1, minus 4 because it passes through, this one passes through this point, minus 2, minus 1, minus 4. We get 4 plus 1 plus 16 minus 4u because you have to substitute x in minus 2 minus 2v minus 8w plus d is equal to 0. So what you get? Minus 4u minus 2v minus 8w plus d plus 21 is equal to 0. This is 3. Next thing is important. Next thing is we have to use, this is 1, I take this as 2 and 3. 1 and 2 are orthogonal. Therefore, 2u1 u2, 2v1 v2, 2w1 w2 is equal to d1 plus d2. d1 plus d2. Now, I take this as 2u, 2v, 2w are already there. We have to take u1 is u, v1 is v, w1 is w, and d1 is d. And u2 I use this one. What is u2? u2 is half, v2 is 0, w2 is minus 3 by 2, and d2 is minus 2. While applying this for a condition of orthogonality, we should write first what is this? u1, v1, w1, u2, v2, w2. Am I correct here? Half, 0, and minus 3 by 2, minus 2. Therefore, 2u1 is u into half plus 2v1 is v into 0, 2w1 is w into w2 is minus 3 by 2 is d minus 2. d minus 2. Now I simplify this, therefore u minus 3w, this 2 cancels, 3w minus d plus 2 is equal to 0. This is 4. This is 4.